and welcome to another ContinuousX podcast where we try to solve for X in the SDLC equation. I'm your host, Mike Fitzurka, and today our guest, Chief Evangelist at Parasoft, Arthur Hicken. We welcome him back for another episode. It's great to have you here.
Hi, Mike. Glad to be back.
I really want to get into today's topic. I have always had a love-hate relationship for testing through the user interface. Or testing through a web and mobile. In my background, I've done a lot of mobile applications. So I think it's a fundamental law. Not everyone follows it, but that you need to conduct functional testing. You got to make sure that your application does what you say it's supposed to do. And that's challenging enough. But, then there's the website and that additional UI layer that a lot of people don't always test through, to be fair. It's something that can change. Here's our holiday screen, and now all of my test cases fail. So it's something that either becomes so manual or so brittle, or you get, I think as we mentioned a couple episodes ago, you get to a set of tests that, well, these ones fail, but don't worry about it. These are the UI tests. Don't worry about those. They don't ever work. So when you get to that, I've even had companies say, "Well, we intentionally don't test through the UI." But I think at that point you're losing a layer of functionality. You're never sure if the next release is working functionally as the user will experience it. So I've heard about this capability, and I'm very excited to kind of discuss it. It's because it is sort of a dream. It's using AI to self-heal failing user interface tests or failing tests at all. Yes, please. How do I get to that? What's actually going on here? Again, we've talked about AI being sometimes you need to keep an eye on it, make sure that it's doing what it's supposed to do. And we talked about getting to a Boolean yes, no, is it good to launch? So how do we implement tests that we've identified their failures, but they're actually okay? And let me change that and make it work now. I'm fascinated.
Yeah, self-healing sounds great, right? It really sounds great. And we've had trivial cases of this for years because, a spelling error, a syntax error, right? Compilers arguably could do self-healing, right? They've been that way for years, and
sure.
And we see it now. See, we don't even trust them to do self-healing because what we see is a recommendation in the editor, right?
Right.
Like it pops up a code completion or a box or whatever it is in the version you see, but we don't trust it. And there's that question of how deep can we trust it today? And I do think that large language models are going to get us to that next level of trust, right? They have the ability to move us past syntax problems into something that's more contextual. They definitely have the ability to understand some context, right? How much we could argue, but I think, if I look at if I sent you a little bot, Mike,
Mm-hmm.
and I got like a little Roomba type thing, and I rigged it up to be a first aid Roomba. Would you be comfortable with it putting a band? Sure, right? You wouldn't be afraid of it putting a Band-Aid on you.
Oh,
Would you
no.
be comfortable with it stitching your arm? Maybe less comfortable. Would you be comfortable with it doing a biopsy? Probably not.
Probably not. No. I trust an AI that does health analysis in the hands of someone who could also do that exact same test, because I wouldn't trust it to work independently.
I think we have a couple of different things that fall under self-healing right now, and we should probably separate them for this discussion. One is I'm going to heal things by changing the test or the code, right? And those are probably two different barriers of trust, right? Mm-hmm. Changing the test is one thing. Changing the code is maybe a different thing, right? And it may well, look, if a test fails because changed code broke the test, then you should fix the test. If a test fails because the code is broken, then you should fix the code, not the test.
Right.
You don't want to make it to conform to the bad code. So it's important to understand that, but the simpler level of self-healing is allowing continuous to proceed, right? The worst thing in the world is to have an 8-hour test suite that you went home confident in the morning you could walk in and have a good day, and find out that 10 minutes into it, something trivial bonks the thing out, right? So self-healing that quickly adapts the remediation, lets your test suite continue. You show up in the morning and, if it was a compiler, then all further tests are meaningless, okay? Like, right. It is true in some cases. But in most cases, I might have a few tests that are meaningless, but I'm going to have a lot of tests that are meaningful. And now I have a small bit of work to do in the morning that I haven't ruined my entire day. And like you were saying, kind of an advisory capacity. If the system tells me that, hey, this thing failed, I healed it thusly, are you okay with that? And you can accept it. I mean, that's functionality we've had for a couple of years now that we've been doing, is allowing people to accept the recommendation that's already been proven in real time worked, right? We tested it worked. And sometimes we see like the AI will come in and talk about your assertions, right? Like your locator was always going to be brittle, right? And this one, we've watched your tests run over the last 6 months, and this one never changes, right? And so not just making a remediation, but making a good remediation, something to make the test suite. And that's really what you want, right? Is something that'll warn you about things that are likely to give you a headache. Any test that captures the entire homepage of your, login is going to be brittle, right?
Oh, yeah. Sure.
Yeah, and people who work in compliance industries like medical, they've learned this because ultimately every test's status has to be passed on to the FDA at some point. And so if you make a change and you change the year, we're going to roll into 2024 here soon, and everything starts failing, do you want to recertify a device because the year number changed? And so learning the right amount of testing and then making the tests robust so they don't fail. We talked about it in an earlier episode, right? But the tests passing should have meaning that something works, but the test failing should also have meaning that it doesn't work and you need to fix it. So AI can actually help, because by observing test behavior over time, it learns what's stable, what isn't stable for you in your code base, right, in your lifestyle. And if it's implemented right, and we haven't talked about this previously, but if it's implemented right, as it's doing this analysis, data isn't leaving your premise, which is
true.
Super important to a lot of your audience, I'm sure. Literally just can't have that happen ever.
And nothing can leave the building. Yes. That is definitely a concern. And that's even some of the code generators. I know that you've got to look at, if you're in that kind of industry, you've got to look at, well, what can I run locally and then still do the job, and so that I'm not sending any information out, because here's all my code. It's not something you want to do in a government agency. And now tell me what's wrong with it. Pinpoint that.
Exactly. Yeah. So, like when we do our some of our models, we've got things that have been trained on a bunch of code, and then we come to your site and we deploy it, and then it looks at what you're doing, but it's like comparing it to the models that it already has. And so everything is local. There's no security, privacy issues, right? Nothing that you had ever leaves the building, because yes, it is. I mean, imagine that I was using ChatGPT to generate some really valuable code. Did it Does it now know how to do that thing? That thing that I spent days, weeks, months learning how to prompt it properly, and me doing part of the work and giving that to the chat bot, does it now, like when my competitor comes in tomorrow and asks the same question, does it get my answer?
I think it depends on the feedback loop, but yeah, I'm sure that the next version might have a remnant of that conversation in there. Yeah, or that code. Yeah.
Yeah, when we talk about best practices, right, that's one of the killer ones. So I do think healing is super exciting. I think healing is very interesting today in terms of continuous, because temporarily healing, right, heal and continue is very effective right now. And ultimately, we're starting to see, healing move down through the layers, and healing gets you to where you can get an answer again, all the way down to static code analysis, where we're getting LLM remediation advice today that will tell you how to fix something, and that's always it's the final step before you get there, right? Everybody has to get comfortable with it, but look at how much of our planes and cars have code that's generated from model-driven development. You're telling me the computer isn't generating that code? I mean, those markets are very comfortable with it already.
Right.
They should not mind something coming in and extending that slightly further. So it'll be interesting. Plus, I think healing is almost a required capability now, because if we have LLMs, the first thing people are going to do is use it to generate more tests. That's the very first thing people do. Let me go generate a whole bunch more tests. Now we have more tests to maintain. We have more tests to execute. We have more tests to fix. And self-healing is the only way that we're going to keep up with the increased test creation, right?
Yeah.
Test maintenance.
Every test that you write, as important as they are, makes that next change almost that much harder. It's not just changing that one line of code. Now I've affected 100 tests, and I've now have to adjust those 100 tests. I think one thing an LLM would be able to help with as well. I mean, usually, if a test works, a test works, a test worked. Today it failed. What changed? What was the thing that changed? So you can isolate, like, okay, well, this is what's launched last night. The error must be somewhere in here in this code. It's usually what changed, and 99% of the time. And that, I think, it might help LLM narrow it down even more and say, okay, well, if it's a code problem, if this is exhibiting the behavior you want, well, then the test is at fault. If it's exhibiting the behavior that you didn't want and I caught it, well, then your code maybe make an option either or. Fix this or fix that. And that's something I'd be happy to walk into the next morning, when after a minor release with only a little bit changed. Okay,
we have the variance, right?
Yeah,
you're not analyzing everything anymore. You're analyzing meaningful variations and deciding whether this was a code problem. And if you had an answer for both, and just you got to go pick, then your life is good.
That is the world I want to live in. That's where I want to be.
I wonder how much, like a related technology to self-healing is the test impact analysis, right? The ability to know what changed last night. Was it a requirement? Was it code? Was it a test? And what do I need to run? Right? And again, at a compliance level, at some point you have to run everything. That's a separate use case. But in continuous context, I don't want to run things I don't need to run.
Sure.
And if I have a very big, we find, like in our own nightlies, that using test impact analysis to only check code that changes, we can end up with, running 5 or 10% of our test suite. Like the performance improvement is massive. And again, the noise level goes down because you're running less tests and you can quickly get to the problem. And at least a system that can do test impact analysis can tell you what changed last night.
Right. Good.
That's why I say it's a related technology, because now this failure is coming. I can say, well, look, these are the only files that changed. These are the only tests that we ran, and we did because of these changes in the requirements, or these changes in the code, or these changes in the test. Those are the only reasons you rerun a test.
Right.
And the cool thing is we've gotten it to work now through microservices, right? So that we can drive through like a funny test that's on a big web application that's microservice A, and then it goes to B, and then it goes to D, it skips C, and we can drag all of those things into play. So again, you know where the failure is occurring.
Very good. Right? Fantastic. Okay, well, I think that about wraps things up for today. And again, I'd like to thank our guest for his insights today and over the past few episodes. As always, I want to thank our viewers and our listeners for tuning in as we continue our mission to solve for X in the SDLC equation.
All right. Thanks so much, Mike. And thanks, everyone, for joining us. And if you have further questions, reach out and pester us. We'll try to make something up.
Excellent. I'll run it through an LLM for you.
Yeah.